Often we hear about large-scale projects that are so ambitious and so innovative with such significant environmental impact that it may be easy to think that's incredible but doesn't really apply to us. And while it's true that every organization faces its own unique challenges, thinking big doesn't just inspire, it creates space for truly big change.
There's a problem in terms of the infrastructure, and that's all real. And there's a solution with technology and innovation today that can make a very material impact on the grids locally and frankly, even on buildings.
There's a kind of magic in asking the what if questions. Like, what if we had unlimited funds for sustainability projects? What if we could fully decarbonize? What if we could run entirely on renewable energy? And then we bring it down to size and we ask, what can we achieve today? That shift in perspective can be powerful. Because the ideas that once felt futuristic and really far off are actually much closer than we realize. And the truth is, that journey doesn't have to start tomorrow. It can start today.
You are listening to Healthy Spaces, the podcast where experts and disruptors explore how climate technology and innovation are transforming the spaces where we live, work, learn, and play. I'm Scott Chu, Sustainability Leader here at Trane Technologies.
And I'm Dominique Silva, Marketing Leader here at Trane Technologies. On Season 5 of Healthy Spaces, we're bringing you a fresh batch of uplifting stories featuring inspiring people who are overcoming challenges to drive positive change across multiple industries. We'll explore how technology and AI can drive business growth and help the planet breathe just a little bit easier. Hello, Scott. What are we diving into today?
Today we're thinking big. The reason is simple. Challenges in front of us are also big. If you take this goal of reaching net zero, or what some people call NZE by 2050, it's massive, and for most of us, it is intimidating.
Totally. And I mean, there's so many voices and opinions and different strategies and technologies out there. It's so easy to feel overwhelmed and just lost in all of the noise.
Well, you said it. There is a lot of noise out there, but today we're going to cut through the noise. We're going to talk about the big challenges. We're going to talk about big projects. Most importantly, though, for our listeners, we're going to help everyone understand what they can do to make a real impact right now.
This actually makes me think of what our previous guest, CFO Chris Kuhn, said last week about the art of the possible. Is that where we're headed, Scott?
Yeah, you got it. To kick
All
things
right.
off, we're going to look at one building, but not just any building. It's a really big building. This one has more than 50 floors, more than 3.5 million square feet of space, and it's the largest privately held commercial office space in America. It even comes with its own postal zip code.
That is a very, very big building, Scott. I think this is going to be a very, very big episode. Let's hear more.
Yes, and to tell part of this story, let's meet our first guests, Dan Polino and Scott Lewin.
Good morning, everyone. I'm Dan Polino. I'm the Chief Operating Officer for New Water Street Corporation. We own and manage 55 Water Street, located in downtown Manhattan. For people not from New York City, not far from the Staten Island Ferry, we could see the Statue of Liberty from the roof of our building. We're very close, a little south of the Brooklyn Bridge. We own and manage 55 Water Street, and in turn, we are owned by the Retirement System of Alabama. And the building is approximately 3.9 million square feet, and it's one of the largest. It is the largest in New York City. We have our own zip code, if that means anything to anybody. That's how large we are.
Scott Lewin, good morning, everybody. I'm the North America Energy Services Contracting Operations Leader for Trane. My experience is in construction, design, build, energy contracting, with a heavy focus on logistics and working on in existing facilities. My current focus is on implementing strategies to achieve outstanding customer outcomes across a wide geography, as now I'm responsible for North America.
You mentioned energy services. What do you mean by energy services?
So energy services, what we're doing is we work with building owners, and we look at their building as their asset. And their asset has to help them achieve a business outcome. So we'll look at how their building is operating and we'll align solutions with their business, with their KPIs, with their business drivers, and to help them achieve their business outcomes.
So, Dan, how do we come together? I mean, I think this relationship, the two companies working together, probably predates all of us, but there's some kind of history there that you must be aware of. How did the two companies come together?
Well, the two companies came together approximately, I guess, 13, 14 years ago, maybe a little longer than that, on the initial projects when we were looking at replacing equipment in the building. And Trane came in, and not only did they look at replacing the equipment, they looked at how could we actually change the operation, make it more efficient, improve the operation. So the first project was actually our ice project. And we installed 134 ice tanks down the basement. We installed 3 new chillers up on the 14th floor, which is the main mechanical room. One of the chillers was an ice chiller. The other 2 were 3,400-ton electric centrifugal chillers. But it changed the whole way we operated the building, and it was really our first big step in improving the energy efficiency of the building and the operation of the building.
So, Scott, let's go back in time. There's obviously been multiple projects. Dan just mentioned a couple. He said it started with something called ice tanks, which our listeners are probably completely in the dark about what we mean by ice tanks. People like me are thinking you put in some ice machines for what purpose? So, let's talk about some of these major projects over time. Can you take us back in time and bring us to the present?
Yeah, so the first project that Dan talked about, and you think about the ice tank as a battery, so it's like a thermal battery.
How big are we talking about? What are we talking about here?
What we're talking about is a tank that is about 5 feet in diameter and about 8 feet tall, and it's got polyethylene tubing circulating inside of it, and the tank is filled with water. That water never leaves the tank or the battery. And we circulate glycol through that. And at night, we circulate really cold glycol and we freeze that tank solid.
So you make a big block of ice.
It becomes a big solid block of ice. And what at the time, and in New York City, the energy rates are a lot less, the energy costs are a lot less at night than they are during the day. So we make that ice at night, taking advantage of off-peak energy costs. And then we melt that ice during the day with cooling capacity that you made at night when the electricity was a lot less expensive. And it was also that electricity was being produced by plants that operate a lot more efficiently. Because during the day, when it's really hot out, the plants are operating at peak capacity and they're operating plants to meet peak demand. When operating and making that ice at night, you're using plants and their peak demand is a lot lower. So the electricity is even made in a much more environmentally friendly way.
Okay, so we're cooling it with by melting this ice during the day. That was the first project. What was the next projects?
And the next projects were focused on the emergency generators. We set up the generators. We modernized the generators to be able to operate in a demand response. So the building has a tremendous amount. Dan, is it 27 megawatts of?
It's actually now it's up to just about 27 because we reclaimed 2 other generators. So we have a total of 18 generators in the building.
So we repurposed a couple of those generators and made them environmentally able to run during the day to deal with demand response. So responding to a request from the utility and being able to run those generators during the day when on the really hot dog days of summer or some other incident happens and the utility needs the building to take demand off the grid, 55 Water Street's able to respond in an environmentally friendly way by using their generators to produce electricity for their own building.
So this year, with the extremely hot, humid summer we've been having, in the last month, they probably asked us to run 75% of the weekdays with our generators for at least several hours because the demand was so high on the grid in New York City.
So it helps the grid be more flexible, right?
It does. It helps the grid be more flexible and resilient.
Scott, was there another project after this one?
Yeah, so the project after that one, and we've done, over the years, controls upgrades. We've been working with 55 Water Street, utilizing our intelligence services with the data that we gather to help them improve their operations and fine-tune the controls by using data analytics and intelligence services.
You're talking about controls, Scott, meaning like controls like things that control the building's temperature, or what are you talking about for our listeners?
Yeah, sorry. It's the building automation system that helps control at its finest, at its end point, right? How Dan's tenants are, their comfort. But it helps control all the pieces of equipment that consume energy. It's also helping control the equipment that's cooling things like computer rooms and other systems. But as you learn more about how the building operates by using data analytics, we're able to then fine tune things and tune them differently to be able to operate more efficiently and more effectively.
So, Dan, what is the current situation? Can you set up for our listeners what the latest goals are for whatever the project we're working on now?
The project we're working on now is we're looking at reducing our steam usage in the building by approximately 70 to 80%, and reducing our total energy impact on it of another 20%.
You use steam currently to do what? To provide heat?
So we use steam to run our the old chillers that we took out of the building. They were turbine drive machines. So instead of using electric to turn a chiller, we use steam to turn a chiller. Very inefficient, high maintenance costs. They were 50 years old, so it was time. And the steam is also used, obviously, for heat in the building
Right.
in the wintertime months.
And you're trying to reduce the steam use by, you said, what was your percent? You said 70%?
We're looking to do it between 70 and 80% in the building.
And besides that factor, what else are you looking for? What are your other goals?
So our other goals is New York City has Local Law 97. Local 97 is a decarbonization. They're trying to reduce the carbon output on the major office buildings. It's going to eventually, I believe, spread to more buildings, but it's the larger office buildings now. And by doing this project, we're looking to reduce our potential penalties of $1.2 million a year to zero by this project.
So you're looking for efficiency on the steam use side, at the same time meeting sort of an external local law that's put in place to help the city start reducing emissions from buildings.
Right, Scott. And the initial intent of the project was I was looking at replacing two 50-year-old chillers, and I was going to do something in kind, electric-driven chillers.
Right.
And Trane came in, and our engineers came in, and they worked together on developing this project. And we call it a chiller heater project, which I was like, what is a chiller heater project, right? So, and I'll let Scott get more into the technicalities.
Yeah, Scott,
on that.
that's an odd phrase there, chiller heater. You want to explain what he means?
Yeah, so a chiller heater, it's using what we would typically look at as a chiller, and it looks just like a normal chiller that would produce
which is
cold
just a big
water,
metal
chilled
machine
water.
that sits in the basement of most buildings, right?
Yeah, these are on the 14th floor, where when you get into projects like
Everything
this,
about 55 Water Street's a bit unusual,
yeah,
right?
55 Water Street is a unique building. So there's these large mechanical machines that are chillers, and typically we use them to make chilled water. And that chilled water gets distributed through the building, through piping to the air handlers, which are then blowing the cool air into people's offices and the restaurant and whatever else is in the building. And so in this situation, though, we've reversed how we use the machine. And if you imagine, like for most people, you have an air conditioning unit at home, whether it's in your window or whether it's sitting outside, you have that condensing unit sitting outside. And if you put your hand over the fan while it's blowing, or your hand next to that outdoor unit, it's blowing out hot air.
It's what we historically have called waste heat, right? So that's the heat
Correct.
being wasted.
So instead of emitting the heat and just throwing it away, we capture it and we recycle it, basically. And then by doing that, we're able to reduce the building's need and demand by 70 to 80% of the steam.
Would you call this groundbreaking, Scott? Is that the word you would use for this, or is this something that's been around for decades that we just haven't been talking about?
So it's been around at a smaller scale. It's groundbreaking in the sense of the way this solution has brought together so many different systems. So it's not just solving an individual issue or resolving an individual issue, it's helping make the building perform better overall. So we've impacted with this project how the original thermal storage project is utilized and impacted, and those thermal batteries are used. We've impacted how they heat and cool the general public within the building, and we've impacted down to how even they heat domestic hot water for the tenants in their buildings so they can wash their hands every day.
I mean, you've taken a lot of creativity on connecting all of these various systems. I mean, gone are the days, I guess, of just come in and cool the building, right? This
Right.
sounds like you're connecting a lot of systems that in the past weren't connected.
That's what makes it
How
groundbreaking.
important is the creativity? And Dan, I don't know if this question is for you, Scott. Both of you maybe can give me your thoughts on how important is creativity in a project like this.
Well, this project, and I've always been very close to the HVAC industry. And when they were developing this project, I was just blown away, to be honest with you. It just puts so much of the systems all working together that used to work separately. And the controls that Trane did in the project to make it all work together, because it's not just a simple project, but by everybody working together, our engineers in the building, Trane, and our design engineers, it's some project. I got to tell you, just the intricacy of it.
Can I just add something real quick? Everything Dan said is 100% correct, but I want to be clear, like, none of the equipment that we installed is like customized here. It's all built for the project, obviously, but chillers have been used. These are the same chillers we use. We're just using them in reverse. It's utilizing existing technology and in a different way by leveraging all the data that we had also around how the building operates and aligning a solution with Dan's goals for their building overall and tying of everything together.
Dan, let's talk about outcomes. I know that, you're the chief operating officer, so you obviously are very, data is very important to you. Outcomes, statistics, things that you can put your fingers on to say this is what we want. What are the big outcomes that you're looking for?
So we talk dollars and cents. We already talked about energy savings in the building that we're looking to achieve. We also looking to be getting about $9.5 million back from the Inflation Reduction Act from the federal government. And we're looking at getting $5.5 million back from Con Ed on this project. It's one of the largest awards they've ever made for a project like this. But it comes down to be a lot more than just dollars and cents. We have prospective tenants coming into the building. And to be able to tell them that we're able to meet local law 97 requirements, to tell them that sustainability for the building, decarbonization to the building, is very important to most tenants right now on how the building is performing. And because it also comes down to our operating expenses. So if we're looking at reducing the cost, it reduces their OpEx in the building.
What's your big takeaway from this project and on the relationship working together? You have a takeaway, Scott?
My one takeaway, I think, is that big things are possible, when creativity, collaboration, and teamwork come together.
Yeah.
The team at 55 Water Street is just, I've been there, Dan's been there, the two of us have been there since that first project. So they're just awesome to work with because of the collaboration and their knowledge of the building and then their willingness to try new things. I think Dan would agree that without the teams that we have and the collaboration between them, outcomes like this wouldn't be possible. If we can do this at the scale we have at 55 Water Street and make it adaptable so that it can be used throughout the year and leverage existing systems and improve those outcomes, we can really do this anywhere.
The 55 Water Street project is a world-leading example of what it takes to move towards a net zero future. What stands out is the collaboration, engineer-led teams working together and committed to the goal. A big learning here is this. It's not just one project. It's a series of projects broken into stages where each milestone naturally leads to the next. It's like a step ladder. That's what decarbonization is really about. It's not one big, all-at-once solution. It's steady progress, step by step, as if we're on a journey. One of the coolest, no pun intended, innovations in 55 Water Street was the system design. They innovated a new way to use water-cooled chillers to capture heat and then reuse that heat within the building. So fun fact, those chillers were manufactured in our La Crosse, Wisconsin facility, which is where Trane was founded by Reuben Trane more than 100 years ago. From legacy to bold innovation, we spoke to Sydney Tharp at the La Crosse facility about a big project that inspired her.
Hello, my name is Sydney Tharp and I work at Trane Technologies as a team lead in La Crosse, Wisconsin. A moment I realized the real world impact of my work would have to be when I found out we were building a unit for a children's hospital. Finding that out changed my perspective on how important what I do is, and knowing that I'm helping vulnerable people definitely gives me a sense of fulfillment. An innovation that I'm a part of that I think could change the world would definitely have to be the heat recovery units we started here in La Crosse. It's super exciting to see and definitely changes the game for sustainability. We have a great team here all around, so I'm super excited to see what the future holds for us.
Thanks, Sydney. Now from a big building, we're going to zoom out to look at the big picture. And my next guest is Holly Paper. Holly's the president of Commercial HVAC Americas at Trane Technologies. Holly shares her perspective on some of society's big challenges and the innovative solutions that are underway that help address them, including something that Dan and Scott talked about, using ice to make heat. Because, folks, I'll admit it, I'm still finding it hard to wrap my head around that one. Hey, Holly, the title of this episode is Big Things Are Possible. And I know you're a very optimistic person, which is great, but we all know that there are some concerns, if you will, maybe a problem that's looming around our electric grid globally and in North America. Sure. It's related to demand and supply. I know you spend a lot of your time thinking through solutions, but there's a problem that we're trying to solve for. Can you help our listeners understand the electric grid issues related to supply and demand?
Yeah, it's a great question, and I think the reality is that it's a big problem, and I think it needs a bold solution. And so, from a problem standpoint, we're hearing about this a lot, and pick most regions of the world. We're talking today about aging infrastructure. We're talking about resilience in extreme climate events. We're talking about demand change with data centers and some of the big new industries that are drawing energy or needing energy in ways they haven't before. And so it is certainly a problem. And, on the same front, there's some rays of light around renewables and maybe how technology like that is being able to add capacity. I think the way that we see it is that if I just look at the U.S. right now, there's twice the amount of supply versus the demand that we need. So we have enough energy if we level loaded and used it in a different way. And so there's a problem in terms of the infrastructure, and that's all real. And there's a solution with technology and innovation today that can make a very material impact on the grids locally and frankly, even on buildings.
Yeah, I appreciate you saying that it's both a local problem, maybe a national problem across countries, and on the demand side for things like buildings needing more energy, it's all mixed up in this thing that we all are calling the energy transition, right?
Yeah, I mean, the energy transition is an interesting one, and we spend a lot of time kind of thinking about this, talking about this, and working with our customers on this. And really, this is about renewable energy and finding ways to use new energy types to supplement kind of the traditional kind of electricity and energy that we've got. What's interesting is that fossil fuel-based energy that we've got today is largely, creating energy and storing it. So it's a stored energy. When we start talking about some of these new types of energy, it is the energy itself, but it needs the storage piece of it. And so, for instance, you think about solar, or you think about wind power, and the way that it's available is very intermittent and very variable. And so that's fine if you only want to use it when it's available, but most buildings and most operators really want energy when they need it, not just happens to be when it's available. And this is really where the opportunity comes in terms of energy storage and what that looks like to try to create a moment where new capacity and new energy sources like this can be actually used in a productive way.
You just mentioned storage, and recently, as part of this episode, I was able to speak to Scott Lewin and Dan Polino about the 55 Water Street project. 55 Water Street, one of the largest buildings in the world and the largest building in Manhattan. And they mentioned something that's known as a thermal battery storage source heat pump. Can you help everybody understand why something that with that long of a name is really an innovative approach?
Yeah, it's a great question. So let me talk about this in a simplistic way, and I'm going to start with cooling, and then we'll go to heating. And so we have technology today that is essentially a thermal battery. So it's thermal storage, but think about it as a battery, but we call it an HVAC battery or a thermal battery. And in fact, the building I'm sitting in right now has 4 of these outside of it. And what happens is every night when electricity is more available and it's less expensive, we purchase electricity to make ice in these big batteries. And they think about this as something that would be maybe the size of a parking lot. So we purchase ice, and then during the day we melt that ice, and that ice is used, the cold water is used to essentially cool the building. So we move it through the building to cool it. The heating side of that, which is a little bit harder to get your mind around, is the same system and it's the same spirit. And so let's say you cool the building during the day. Now you've got water in your ice tank because you've melted it all.
Right.
When you extract heat from that water to make ice, you're actually extracting heat. We use that same heat to heat the building where it needs to be heated. And so you suddenly have a system, a battery, that's able to store energy for when you need it. It's not about using the energy when everybody else is trying to use the energy, but instead being very responsible from a building standpoint. The beauty of a system like this is that, it makes the building more efficient, reduces greenhouse gas dramatically. It's cheaper to operate. And in our building, I think we reduced our operating costs by 40% by putting a system like this in. And so you start to see the magic of this. We've been deploying the ice storage cooling solutions here for many decades, and we have thousands and thousands of these globally. Now we've got the technology, and we've invented the spirit of how you do the same thing with heating, and that's really what's exciting here.
Well, then, Holly, is this only for big buildings like 55 Water Street, or where can it be applied?
It's really an interesting question. So if you think about one of these ice tanks, it's about the size of one parking space, an average parking space in the U.S.
Okay.
And so you need to have space to be able to put these ice tanks there, in addition to the applied systems you have in a building. Right. At the most basic level, they are paired with what we call a hydronic system, which is essentially using water to cool or heat buildings. Mm-hmm. And so as long as the building itself has a technology like that, an applied system and space for this, we see them deployed everywhere. We've deployed them in data centers. We've deployed them, as part of a wind farm installations. We've deployed them in hundreds and thousands of commercial buildings, K-12 school systems, higher education, even some hospitals.
Are you talking about new buildings only?
Not at all. And in fact, we actually, some of the most creative implementations that we have and installations that we have are, 4 floors below the earth in New York City, in buildings that have been here for decades and decades. And we've just found creative ways to take space that was maybe not utilized effectively and to really help our customers and the building operators figure out how to get a little bit creative about how they use their space in the most efficient and cost-effective way as possible.
There's also an emissions play here too, right? I mean, this technology also helps with the journey on reducing greenhouse gas emissions, right?
Absolutely. I mean, I think there's a couple pieces, right? I've said a couple of times the spirit of, hey, if you're purchasing electricity or using electricity when it's more available, not only does it help the grid, and that is net good for all of us in terms of efficient use of energy, there's a cost savings for the customer, but it also reduces the greenhouse gas footprint of the building, in a very material way. One of the things that, we think about and that we're trying to solve for in terms of the business is the whole idea of what it means to deploy technology to be able to help our buildings decarbonize. 15% of global greenhouse gas is used for heating and cooling today. And with technologies like this, it makes a material impact on each building's ability and carbon footprint, the resilience of the building, and makes it a big dent in terms of this greenhouse gas problem that we've got globally.
You spend your time, Holly, I think, thinking about more than this, obviously, with customers and the team that you lead for Trane Technologies and for the Trane brand. And I'm wondering, what have you seen lately that's got you excited? There's always a game changer around the corner, and I personally have a bit of a concern. Sometimes I think that people tend to wait on the next big thing before they take an action, and I think what you've explained here is that we have technologies that are proven today that we can apply to make big impacts. But people are always interested in what's next, and so what are you seeing that's exciting?
Yeah, it's a great question because I like you know, we've got so many tools to solve today's problems. We're thinking about the next frontier and the next frontier
Right.
after that, and how do we keep leveling up? One of the things that I'm very excited about is the idea of artificial intelligence. We've not only been working with technology like this for a while, but the idea of HVAC and building technology specific AI and the use case around how we help a building become almost self-healing and self-optimizing. And so, you know, for decades now, we've built a business on having the best innovation technology, being able to apply it like no one else can. And, you know, looking at a building over the life cycle. So, for instance, in day one, you know, when we install a system, we assume it's born perfect. And with that business model we've had for quite some time, our service technicians and our service capability keep it working as near perfect as possible.
I mean, they have to be maintained, right?
Exactly. That's how we've seen energy savings. But now we've got technology, and we're just on the cusp of even doing more, where suddenly you have AI and tools that sit on top of that help augment kind of what humans only could do in the past. And what that means is that we're able to deploy that technology in a far broader, greater way to more customers and optimize more buildings than we've ever been able to do before. Our technicians and our service capability is still tremendously important, but we're using those scarce resources now to serve even more people. And the more we can bring the technology, the innovation, and AI, that combination together, it just means that we can help more buildings save money and have less greenhouse gas. So I think the acceleration and the scale that we can get to with technology like this is super exciting.
Thanks for the example of how the technology that you just mentioned it can be incorporated to help a building achieve greater efficiency. But you also mentioned the people element here. And our listeners who may have looked you up on LinkedIn will see that most of your posts are about culture and people. You are a culture champion. So I can't let you go without you talking about your views of the importance of culture and people to all of these solutions.
Yeah, thank you for asking about this. I think this is the key to it all. And, you know, it's ironic, right? We all know that, you know, we want to have a broader mission or a noble cause. And we've watched that play out. I've watched that play out at our company, just even over the last decade, and how, you know, sustainability and, you know, has rallied our organization around kind of this noble cause. And the reason that matters, right? The reason that matters is that's where the unlimited fountains of energy that people bring to solve problems come from, right? It's one thing to have a job at a company that you're generally interested and excited about. It's another thing to be rallied behind something you believe at the root of who you are. And, you know, so I think this idea of culture and noble cause becomes really important. The part of the reason that I think being a culture champion is part of my role as a leader and as a human, as a mom, and all the things is that, you know, we need the next generation workforce to be able to continue to innovate, to find the next idea and the next idea. And, you know, the spirit of what that looks like in terms of, you know, seating in schools and philanthropic organizations, you know, finding ways to inspire people to come into the industry to solve problems. You know, when we solve that and you put that together with the magic of culture and this noble cause, that's when real innovation happens. And so I believe that this is something that's so materially important to not only our company, but the industry, and being able to provide impact way beyond what we are all doing here today.
Holly leaves us on the perfect note, the power of culture.
I love that, Scott. And we heard that in Dan and Scott's story too. I mean, when people come together to commit to the cause, anything can happen.
Yeah, exactly. And I think the biggest takeaway from both of these conversations, Dominique, is that you do not have to be big to achieve big things. You don't need your own zip code to drive big change. There are so many actions that any organization, no matter its size, can take today that can have a lasting big impact.
On that note, I actually want to hear from our listeners. So, what has been the most meaningful sustainability step that you've taken recently? And that can be anywhere, at work, at home, even in your community. Leave us a comment and let us know.
And that's it for this time. This has been the Healthy Spaces Podcast with me, Scott Tew, and my co-host Dominique Silva. To learn more, check the links in our show notes. Want to stay on the front line of innovation and sustainable growth? Subscribe to the Temp Check newsletter on LinkedIn and stay in the loop. We'll be back in 2 weeks, so be sure to like and subscribe so you don't miss out. Thank you for joining. We'll see you next time.